Thanks everyone who's taken time out of their busy schedules to join us. Just a quick reminder that Waterloo Hydrogeologic produces a comprehensive product suite for the entire life cycle of environmental groundwater projects. So we have 4 main software packages that are shown on the screen, and we'll be talking about AquaChem today. So we'll be going over a few brief points before getting into a live demo. The first will be what is AquaChem, why use it, a brief introduction and overview of AquaChem 9, including a demo, and then we'll have a Q&A session. So first of all, what is AquaChem? It's a water quality analysis software typically used by a wide variety of disciplines to manage environmental data, plot it, perform statistical analyses, do some QA/QC on the data, and also reporting. It's used for a wide variety of applications. AquaChem stores and manages your environmental data in a single structured format that allows you to quickly develop advanced and dynamic water quality plots and other reports, and allows you to take advantage of some built-in geochemical calculators, and also the new version will be able to run R scripts. So why use AquaChem? Traditional approaches to data management use spreadsheets or field reports and spread across different formats with little standardization, sometimes unreliable or inconsistent quality. Some examples might be where you might call in one spreadsheet PCE as opposed to perchloroethylene. You might have a hard time mixing and matching those data and building one unique data set. Sometimes there's multiple copies. If you have an integrated data management approach, you use a central database that has a consistent data structure that stores quality data and that acts as a sole source of information. Obviously, one approach is much better than the other and leads to a lot of efficiencies. The basic approach of AquaChem is to have a data management pillar that allows you to do analysis, which then provides you insight. That leads to a greater understanding of your data and also allows you to share any insights you have with your project stakeholders. The way AquaChem 9 is structured is a central access database similar to the original versions of AquaChem. We've made it into a series of modules, and there's 3 different kinds of modules that interact with the data. There's the data management aspect, some analysis aspects, and modules that provide you with insight. In terms of data management, we have a template manager that allows you to easily customize your data structure and also put some constraints on it. We also have the ability to import data sets from a variety of sources and then manage your samples, edit your parameters, and also create lists of parameter groups, and then import and manage water quality standards. We also have the ability to analyze and present data. So there's a station list and data views that allow you to manage sampling location information. Similarly, we have a sample list view and a sample set editor that allows you to manage sample information and build lists of samples that are either static or dynamic, and we'll provide examples of that. There's some built-in calculators that should be familiar to those of you that have used previous versions of AquaChem. And then last but not least, in fact, it's the main show, the ability to create plot collections. We have over 19 different types of geochemical, statistical, and generalized plots that you can create. In terms of insight, we have a newly built R console that allows you to build and run advanced statistical analyses and other analyses using R scripts. I'll show you some examples of that as well. Build sample reports to pivot your data and compare your results to water quality standards or evaluate generalized statistics. In terms of facilitating report generation, we have the print to office feature, which allows you to print your tables and plot collections to custom office templates that are print ready so you can build them directly into your reports. In terms of comparisons to previous versions of AquaChem, we've sort of added in the main components and showing which features have been ported over from AquaChem 2014 to AquaChem 9. So in the case of data management, we have most of the functionality ported over. There's some limited ability for the QA/QC to work with the template manager. We will be adding a little bit more functionality in future releases. The same thing with data analysis. We've brought over most of the core functionality. We didn't have enough time to add in support for FreakC, but the components that we've brought over, I think we've done a better job and made things far more efficient. And then in terms of insight, we've done a really good job of bringing most of that functionality over in a very easy to use format. So in terms of common questions that we're encountering with some of our early users, will any of the missing 2014.2 features such as QA/QC, trend and outlier analysis, freq-C, and shapefile plots be reintroduced? The answer is absolutely. We'll be adding those features back in over the next releases, and we'd like to get your feedback on helping us prioritize the order in which those are reintroduced. And you can import your AquaChem 2014 projects fairly seamlessly. All of the data will be migrated over. You will have to recreate some of your plots and reports, although I think you'll see that doing that is actually really straightforward and a lot more powerful. If you're really wanting to use, say, freq-C, AquaChem 2014 is still available and can be installed on the same computer and can be run in parallel with AquaChem 9. So without further ado, let's skip over to our live demo of AquaChem 9. When you open up AquaChem 9 and have a project open, the first two things that you'll see are a station list and a sample list. And these are present in our workspace area. We also have an area called the Project Explorer, which includes the project tree, which has a listing of all the relevant information in your project, as well as a station picker and a sample picker. These station pickers and sample pickers are live, so if you click on a station in the station picker or in your station list, they will get selected throughout the application, and I'll show a presentation of that in the plots as well. This is something that most of you that are familiar with AquaChem 2014 are also used to. So the station list presents all the information about your samples. It can be extended using the template manager. So you can add or remove fields and create lists or restrictions on what values are present for each field. They can be added or removed with the exception of the name and the location. The sample list is a list of all the samples, and similarly it requires a sample ID or a sample name and a station that it's tied to. Fields can be hidden or shown. So in this case, we've decided to show all of the relevant information, including the date and some symbols. Beside the sample list, we also have all of our measured results. So this is the list of all of our parameters that we've sampled for in this particular sample. You can click through samples and that gets updated. You'll also note that certain samples have been highlighted, and that's because they've exceeded a water quality standard, and those can be imported from the samples menu, clicking on the water quality standard. You can import multiple water quality standards. There's no limit on the number. You can have more than 3. These can be imported either by creating a new standard and manually entering the values or by importing from Excel or text spreadsheets. You can enter in various values, including a name, a short name, and then also an exceedance color, so that any samples that exceed that standard will be highlighted with those colors. Going back to our sample list, we can also filter the results by any set of parameter lists. So if we only want to look at cations, we can filter the list to just the cations, or organics dissolved or total, and see the results there. These lists can be customized using our parameter list editor. If you have a list, it will show up here. You can create new lists. So say we wanted to look at organics. We've created a new list, and we could filter this by looking for, say, TCE, adding that, and PCE, and so on and so forth. So you can create these sets of lists and then save them. And then once we've saved that, we can go back to our sample list and then filter to those particular constituents. That's pretty much that for a parameter group editor. You can also edit individual parameters or create new ones. Note that these ones highlighted in yellow are required by AquaChem. These are to drive various calculations or specific plot types, but you can add in any kind of parameter similar to how you would have done in AquaChem. And the following information is available to you. Note if you create a formula, say we've got calcium, and just as an example, if we wanted calcium hydroxide, we could also adjust the molecular weight based on this formula. Other things to note about the sample list are there's also a calculated tab. These functions are automatically calculated for you. You have general water quality parameters such as ion balances or calculations of the total number of anions or cations, electroneutrality, total dissolved solid estimates, some agricultural parameters such as the sodium adsorption ratio and the magnesium hazard, some scaling indices, Larsen, Skold, Picorius, various other ones. You can turn on and off these calculations by going to Project and Properties and going to the Functions tab. You can turn these on and off and also change their labels and change what units these are calculated at. Also of note, you can map these required parameters. So if your parameters are named something different, say this was called calcium, you could go into your database and make sure that AquaChem understands that what you've called calcium is calcium and it is mapped correctly. Other calculations that you can perform are the water type calculations. So we can go into samples and show you how that's set up. You can calculate water type by mapping it to a particular field in your sample list, and then either using the long water type, which uses a threshold, a minimum percentage of the total ion content to include the water type, or just calculate the short water type by turning that off, and only the top anion and cation will be created. These automatically get populated here, and so if we highlight some of these samples, we could calculate it for the select samples, and you'll note we have the water type calculated here. We can go back, calculate the long water type, and that's fine, and we'll now do it for all of the samples in the list. All right, so now we have the water type for all of our samples. So going through the project tree, one of the things you'll note is that we have lists of stations and of samples. And the way those can be created is we have a sample set editor that allows you to create conditions that will create dynamic queries. So one example that you can look at is, say we want to find all of our samples that exceed 250 milligrams per liter of calcium. We could also add other conditions. So these conditions can be based on a parameter value. So in this case, if we wanted to add calcium greater than 250, we could have done that there. Or if we want, say, magnesium less than some value, greater than or equal to some value, we can also, instead of just a parameter value, not just constituents, we can also look at station parameters. So if we wanted the station name starts with MW, and then add that condition. We can also get a preview of which samples that will return, and if we save it, then it will get added to the project tree since we already had it there. It's there. I'll show you how to create a new one. So we could also do exceed some standard. So we could have any parameter or a following parameter. So let's say we want TCE. Actually, that's not showing up because it's in station parameters. So if we look at analyze parameters, there's TCE. We can click OK, and we could say if TCE exceeds any standard or a specific active standard. So let's say it exceeds the MCL. and see a preview of that. So these are all the samples then that exceed the MCL for TCE. If we save that, then it gets added to the project tree. We can rename it TCE exceedances, and then we have that later for future use. Another nice thing is if you're running quarterly reports, we could add in a condition, sample parameters, and look at the sample date, and then we could add in conditions for, say, since the beginning of the year. In this particular project, we don't have any of samples that are newer than this year, but the idea is there. You could also add in a less than and then bracket the sample set. So in this way, you can create sample sets that then might meet the needs of your project. If you're running quarterly reports or periodic reports, you can adjust those quite quickly. And then we'll show you how those would be used. So one of the main features of AquaChem is obviously the ability to create plots. As I mentioned before, there are 19 different plots that you can create. Each of these are listed in this example. There's a table of contents, so you can skip through to each and any plot you'd like. You can also add multiple plots to a single page. So if you want to show multiple plots at the same time, you can do that. They may get a little bit crowded if you have too much information on there, but for larger page sizes will plot appropriately. You can also reduce the number. So we'll look at some of the individual plots. There's the box and whisker plot that allows you to plot generalized statistics about some of your results by station. You also have some of the main geochemistry plots, the Durov, stiff, and Piper plots. As I mentioned previously, if you click on some of the sample pickers information, then you can highlight one or more samples. And if you're showing multiple views at the same time, if you're looking, say, at the sample list, you can also click on various results to see them highlighted in the plot. You can also click on the plot to show which samples they are. This will help you identify interesting data points such as outliers or other data points that may not fit expected trends, or maybe do fit expected trends and you want to figure out what's going on. Certain plots also have the ability to add in lines. So if you wanted to add in, let's dock this back in our main view here. If you wanted to add in a line of best fit, you could add in, say, a 1-to-1 line. And click apply, and so you can see that. You'll also notice that in this particular plot, we're plotting sodium versus chloride in milligrams per liter. That's maybe not as useful. We may want to actually add in different axes. So what you can do is pick a different unit axis, and in this case, we'll do milliequivalents per liter for the x-axis, click apply, and also for the y-axis. And this way we now have a more standard basis to compare sodium versus chloride. So all the standard plots that were available in 2014.2 are available in 9. Let's see. And also one of the things that you can do that's fairly new to 9 is if you right-click on here and again go to the source data, you can pick where the data source is coming from. So in this case, we can pick active sample set. And if we change our sample set, all the plots in that collection will update. And so we can see that now we're only running the data points for the active sample set or the active station group. So if we wanted to pick all stations, we could get all the data. This takes a little bit longer because I have a few extra plot collections open. One of the ones that I've set up here is for geochemistry, and you can see that we've got a Piper plot, a Durov plot, and a Schoeller plot, as well as a stiff plot And the way they've been set up is that they dynamically update. And so you can see that if we click on various samples, that each of the samples will get highlighted in each of the plots, and then the stiff plot has been set up so that it shows the values for that particular sample that's selected. And the way you can verify that is it's just the active samples. If I select multiple samples on the stiff plot, it will calculate the average of those values. You can also create static lists of samples. So if you select a certain number of samples, you can right-click and either add those samples to a new sample set or to an existing sample set. And that list will be a fixed list that you can edit. Another nice feature is the ability to create sample reports. What this allows you to do is pick a set of samples either based on a station group. So a station group includes all the samples that belong to a certain set of stations that meet some criteria, or a set of dynamic or static sample sets. These are color-coded, so a dynamic set is green while a fixed or static set is blue. And the same applies with station groups. A special station group that's permanently built into AquaChem is the All Stations group, which both acts as a list of all the stations and as all of the samples. The next part that you can do to build a report is pick a set of parameters. In this case, we've selected our major ions plus pH. You can also select which statistics you'd like to calculate and then show the various water quality standards. So you can show all selected parameters or filter your list based on parameters that have applicable standards or only those parameters that have exceedances. In this case, we'll run all selected parameters. So if you click execute, you'll get a list then of all those samples, and then also for each of the parameters along with the output unit, and then any standards that you might have along with all of the exceedances highlighted and results and values. We scroll all the way to the end. You have a count of the number of samples, exceedances, and all the summary statistics that you've added into the report. This can be exported out to either a PDF using the Print Preview tab. And bear with me a second. So you can get a preview of a PDF and then save that, or you can also export it to an Excel datasheet. I should also mention that you can save any of these plots that you create in plot collections as images, and you can print them to any file format at a specified resolution. So here are the file formats for images. You can also specify resolutions, custom or predefined, and then save them to a folder. And if you have multiple images per page, you can also create one image per page or one image per plot, and then select which plots get exported. So this allows you to create reports quite nicely. You can also print directly to a PowerPoint template, and we'll print the whole plot collection and one image per page. So I show you what that looks like. Create a report. You can also save it to anywhere, but in this case it'll get saved to your project directory. So if I click OK, it'll take just a minute to plot it up, and we now have a nice print-ready set of charts. You can go into PowerPoint and change the project title either beforehand or after the fact, change your figure titles for each of the plots, and set up the date and figure number so that they come in automatically, as well as client name or your company logo. Other features include the ability to create the plot collections. You also have a symbol editor. So what this allows you to do is customize your symbols using automatically generated lists. So if I create a new symbol list, say I wanted to create a list by the water type. Now this one already exists, so I'll just call it water type 2. Click OK. And now I have a new set of symbols for the water type. I'll save that. And if I click apply, if I go back to my geochemistry, you'll note that all of the symbologies have been updated. So this allows you to quickly change your plots to customize them to what your needs are. And certainly last but not least, we have the R console. So what this allows you to do is create R scripts. For those of you that are familiar with R, it's a statistical language that's been around for quite a while. It's used a lot in academia and is a very powerful scripting tool that has tens of thousands of libraries that are available to you. In the demo project, we've predefined scripts that hopefully will be able to help you, and I'll run through some of those. As part of the demo, we've walked you through creating some of the parameters. So within this interface, you can add in variables based on your data field. So if we click on, I'll back up a minute. If we click on this project tree, this is our entire data structure. So you can go into the station table, double click on one of the fields, in this case station name, and create a new variable based on that field, and then filter your data based on specific station groups or getting all the data, or you can get it from a specific station. So in this case, we'll just get all the data. And what that does is it inserts a variable where you have the cursor located, allows you to then generate lists of parameters. I'm just going to go ahead and save us a little bit of time and uncomment some of these fields just so that we can run the script and show you some of the things that the scripting is capable of. This particular script, what it does is it goes through the sample table, it pulls all the information from a particular sample set, calculates some basic statistics, and then performs a Mann-Kendall test for you. So the example test is in here so that you can maybe mix and match that for your use. So I'm just going to go ahead and run that script to show you what it looks like. The first thing it does is it outputs a series of data frames to the text. If we widen the screen a little bit, it shows up a little nicer. Let me hide our Project Explorer. So you can see the data frame. This is also, as part of the script, exported out to a CSV so that you can open it in Excel and manipulate it there. But just as importantly, it's also creating some graphs. So this is a correlation matrix that shows the correlation between all of our major ions, and it shows strong correlations between, in this case, bicarbonate and magnesium, and a negative correlation with carbonate and bicarbonate, which kind of makes sense. And so this could be a very valuable plot if you're trying to look at the occurrence of some parameters within your sample versus others and how they relate to one another. Another very good script, or fairly powerful script, is the script example 3, and I'll show you that. Just uncomment a couple things. This is pulling information from our station data table. We're going to create a map, create some plots about our station information, and then also get some sample information. And the way that works in terms of getting sample information, you'll also note that there's an interface that allows you to pull information concerning parameters, whether it's station parameters or your various analytical parameters. So if we wanted to get information about magnesium, you double click on that, a window should appear. There we go. So you can create a variable name, in this case it'll be magnesium, or select a different parameter if you so choose. Pick a unit and then create a scope for it, whether it's a particular station group or sample set that you want to define. In this case I'm going to click cancel just because everything's defined here. So I'm going to go ahead and run this script just to show you what it can do. So the first thing it did was it created a map in my default browser. And this is a map of our station groups. You can click on any of these icons, and I've set up the script so that it can provide some basic information about each of your locations. I've also added a little feature so that they converge into points. So if you have a lot of sampling locations, you'll be able to collapse those into information bubbles that way, which is quite useful. Other than the browser, I've also got a series of charts, and I'll scroll through those. So the first is you can create sort of just a quick and easy map there with locations, also an elevation profile, chloride concentrations over time, some scatter plots, and then also a concentration plot as a time series with trend lines. This pretty much highlights all of the major features that we have. One thing I should also mention is the ability to import data. You can import data of 3 different types. The sample import is geared towards the structure of AquaChem and allows you to import stations, samples, and analytical data, and puts the appropriate information into each of those 3 tables. There's a generalized import that allows you to import into one table at a time. And then finally, an image import that allows you to import pictures into a particular table, largely focused towards stations. So I'll just show you a brief example of how to import some samples. Supported data types are access, text, and Excel files, as well as CSV files. So we'll import this chemistry.xls file. There's 2 different options that most of you should be familiar with if you've used AquaChem 2014. There's analyzing samples as in a flat format where one analyzed value occurs in each row of the data, or as a sort of pivoted data set where you have samples as rows or columns. I'm going to show this example of just one analyzed value per row. So here we're importing some stations with sample IDs, having BTEX and TCE that's coming in with some qualifiers and a result unit. So using this sample import format, we have particular tables that you can import. We can also add in other tables that are linked. So in this case, I've added the station table because we have some station information. So each one of these is then mapped. So this is the structure of our AquaChem database fields. And then we also have the input source formats. So in this case, I think we have enough information. We just want to import the station name. We also have our samples. So we have a sample name. Unfortunately, in this case, we don't have a sample date, but what we could do is add in a constant. Say the samples were collected last month. Add in a constant there. And then we can also add in our station name and add in another constant. None of these are representative. And then in terms of analysis, we would have our parameter, a value. The units are actually mapped up here. And that's everything we needed to map. So then we can go ahead and click next. If this is something we're going to be doing a fair bit, we could actually, if we've already saved the settings for import, we could select a previously mapped set of import steps. At this step, AquaChem checks to see that all the parameters that you're importing exist in your database. If they don't, you can create new ones, or you can map missing ones. So if say benzene was missing, and of course we have to filter the list accordingly, we could map it that way. Same thing occurs for units. Before finalizing the import, you'll get a preview of the data to be imported into each of the tables that it'll be imported into. And at this step, you can save your import steps and your mappings. Finally, we click import. We'll get a summary of all of the records that have been imported into each station or into each table, and then what type of import it was, whether the records are new or updated, and then previews of each table. Then we click finish, and if we go back to the sample list, we'll notice that we have a few new samples and a few new stations. So at this time, I'd like to open it up to questions. If anyone has any questions, please unmute your phones and ask away. I see there's a question that if you need to use the trend analysis or Freak-C, can you get 2 licenses? Yes, if you're an existing AquaChem license holder, then you can continue to use AquaChem 2014, no problem. If you're new to AquaChem, when you buy, you'll be provided with 2 serial numbers, and you can activate them both separately. And both will be active, so you can continue to use AquaChem 2014 without any issues. Hopefully that answers your question.
Yeah. So a quick question is about the name of the parameters. All these are in English. So what if you need other languages?
You can absolutely create lists of parameters that are in any language you like. There's no real restriction. The one thing that I should mention that's sort of tied to that is, let me bring back AquaChem, is if in your project settings, the only thing you'll have to do is go to parameters, and you could name it that there, and it would show up as you've named it in Spanish here. So it ends up closing a couple things. I'm not going to save any of these changes. So I go to the parameter editor, I go here, and the display name would be photo. So we're going to save that, and then what you do is, again, go into your properties and parameters. I can't remember if it renamed it. Yeah, so there it is. You go in there and you'd map it, and it would know that Clodo is that. Although in the background, Clodo was given the CL prefix, but that's how you'd remap things, or how you'd map them in the first place.
Okay, so you will have to specify. So now you're thinking about, in some cases, to have in the table you may have the name like nitrate or ammonia.
Yes.
And not the prefix, right?
It's kind of up to you how you set it up. And in fact, another thing that I actually should probably show everyone is that if you're creating new parameters, so in this case, if we wanted to create a new parameter, you could do that. So you can create them within AquaChem itself. And we'll do, oops, 10 milligrams per liter. Click OK. Calculate our molecular weight. We'll save that. First of all, that'll show up. Now I can remap that just so that to show you that it actually can and will show up in your sample list as Clodo. So go to properties and then remap that. Oops. There it is. It's in there twice, but that's fine. We remapped it. There we go. It didn't update here because it's still the original one, but if we add it in, so it's actually a new parameter. We go there. There's our results for chloro. One of the things that you can also do is we have the ability to go into AquaChem. There's a chemicals list. So there's a standard one that's been created, but you can go in and edit that. So anytime you're adding parameters, you can also add them from this database. This is a shared database, so you can save it anywhere in your file structure, including on a network drive, and then share it across your organization. So if you have a list of constituents, you can easily create that. You could create new chemicals, delete chemicals, or add them. At the moment, we don't have an import feature. That's something that we'll work on for the next version, but you'll be able to import those lists.
Thank you.
And I'd like to thank you once again for spending your valuable time with me this morning or afternoon, depending on which time zone you're coming from. And have a great day, everyone.